Hello student, last lecture we continue the topic area of triangle using determinants. Now we have the area of triangle formula. Area is equal to plus minus 1 upon 2 x1 y1 1 x2 y2 1 x3 y3 1, where the vertices of triangle are x1 y1 x2 y2 and x3 y3. In previous lecture, we directly take the first row, first column, first row, second column, first row, third column common. And we have to take the coefficient of that and cofactor of that determinant in a 2 by 2 order. Let us try some another examples, pattern and another method. We have to solve the same area. Let us check. Find the area of triangle whose vertices are 5, 2, 7, 1, minus 2, 3. So, I put the x1 5, x2 7, x3 minus 2. Our y1 2, y2 1, y3 3. And the last column is 1, 1, 1. And 1 upon 2 keep as a same. So, 1 upon 2 same. So, in this another method, I take the coefficient 1, minus 1, 1 outside the 2 by 2 matrices or 2 by 2 determinant. It is applicable for matrices also. So, now which now we have to take? We have to skip the first row and the last column here. So, what is remaining then? 7, 3, minus 2, 1. So, we should write 7, 1, minus 2, 3. Okay. Next minus 1 is there. So we have to skip now which column? Second column and first this last column. So we have to derive 5, 2, minus 2, 3 also. Okay. Next last column. Now which row we have to skip then? Minus 2, 3, 1. So 5, 1, 2, 7. It is the same. Okay. I explain again. In this method, we directly take 1, 1, 1. We have to fix the last column. What is that benefit? I put 1, minus 1, 1. Now we have to skip now rows. In previous method, we have to skip the columns. Here we have to skip the rows. Now we have to take the first row and first column is last column is skipped. So what is remaining? 7, 1, minus 2, 3. So we should write here. Okay. Now we have to concentrate on the last column, second example, that is 1. That is one element. So we have to skip the second row and last column. So what is remaining? 5, 2, minus 2, 3. Next one, we have to skip the last one. So last row and last column. What is remaining? 5, 2, 7, 1. In this way, we have to solve the 2 by 2 order determinant also. It is also applicable. In previous method, you have to take the first row constant and column we have to change. In this example, we have to change the row and we fix the column number 3. No matter. So let us try 1 upon 2 fix 1. Obviously 7 into 3. It is 21 and minus plus 2. So it is plus 23. I should write the direct answer. 5 with 3s are 15, 15 in plus 4, 19, 5 ones are 5, 7 into 2, obviously 14, 5 minus 14, so it is minus 9. So we have to simplify, it is minus 5 upon 2, but area is always what? Positive, that's why minus it is become plus. Let us try one more examples based on this method, so you get a brief idea about that thing. Find area of triangle whose vertices use matrices to find area of triangle. It is the most probably in matrices chapter we have to discuss this in a detail. But it is brief idea to get here also. So we have to take 5, 2, 7, 1, minus 2, 3 are the elements. 5, 2, 7, 1, minus 2, 3 I write here. 1, 1 is fixed. Okay. So let us try so our format. We have to skip the last column fix. We have to skip now first row. What is remaining? 7, 1, minus 2, 3. Okay, right? So 7, 1, minus 2, 3. Next, 1 upon 2 is fixed. So next one is minus 1. We have to now take the second row and last column fix. So what is remaining? 5, 2, minus 2, 3. Next, last column. Now last row. What is remaining? 5, 2, 7, 1. We derive the 5 upon 2 answer. Yeah, the same example I carry forward for the matrices area of triangle. Now next example, minus 2, 1, 0, 4, 3, 6. We write minus 2, 1, 0, 4, 3, 6. 1, 1 remain as the same. So what we should take the first, that is I write here directly. We have to skip the first row and last column. What is remaining? 0 into 6, 0, 3 4s are 12. So we should write minus 12. Okay. Next one, we have to skip now second row and last column. What is remaining? Minus 2, 1, 3, 6. 6 into minus 2, minus 12, and 3 ones are minus 3. So minus 12 plus minus 3 is minus 15. Now last row and last column, what is remaining? 4 2s are minus 2s are minus 8, and 0 into 1 0. So minus 8 is the answer. Simplifying, minus 12 into 1 minus 12, minus minus plus 15. Next one, 1 into minus 8 is minus 8. We simplify and we derive the final answer is minus 5 upon 2. The same trick follow for the area is not always negative. That's why we find the area is 5 upon 2 square unit for these vertices given below. Okay. In both the methods, you may find the area of triangle. I only introduce the second method for your convenience. Both way we have to find the area of triangle. Now our usual practice makes perfect. So that is why I give example for practice. What I give? Find the area of triangle whose vertices are 5, 8, minus 2, 1 and 1, 4. Find the area of triangle whose vertices are 3, 4, 5, 7 and minus 2, 3. Compulsory practice on this example and solve this example. You did have the right answers. I hope so. So, up to this topic, what are the application of area of triangle in our real life? That is the main question we have to ask him. In this diagram, you see something interesting. So in this there is an explanation. This is the map of any country. Let us Miami, Puerto Rico and Bermuda. So that's why it is called a Bermuda Triangle. And the triangle is formed by imaginary lines connecting the Bermuda, Puerto Rico and Miami, Florida. Use a determinant to estimate the area of Bermuda Triangle. To find the area of triangle, that is the Bermuda Triangle, we definitely use the application of area of triangle using determinant here. So that is the application of the area of triangle. In this picture, what should you see? I write here kite. Okay. But it is in a mathematical language, it is the quadrilateral with two pairs of adjacent sides that are equal. Obviously, this side and this side of equal in a quadrilateral, and this one adjacent side is also equal. We have the symmetricity, line of symmetry. Obviously, we have to fold this. We have to take the axis here. Rational symmetry is not always possible. So in today's lecture we have to must define the area of quadrilateral. Okay, so I use these in previous diagram. It is the vertical view. We have to let us take the example based on the horizontal view, and we have to get exact area of quadrilateral using area of determinant and area of triangle. It is interesting part. Let us check. Find the area of quadrilateral whose vertices are given. How to find that? The area of RQPS is what? We have to find. If we find this area of triangle and add, we get the total area of this quadrilateral. How? area is a bracket triangle. Which triangle I consider first? RPQ. Next, plus area RPS. So we take the RPS. In a quadrilateral, this is the horizontal view, and here what you see that these both sides are equal and these sides are equal, and this is the axis that is called the diagonal in a mathematical language. In geometry, you detailed study about the quadrilateral. So let us define how to find the area of quadrilateral using examples. Let us try. Find the area of quadrilateral whose vertices are 3, 4, 0, 5, 2, minus 1 and 3, minus 2. So I given capital A x1 y1, given part I should write b1 b is equal to x2 y2 0 5, x3 y3 c 2 minus 1 and d x4 y4 d 3 minus 2. So all four vertices are given and diagonals are BD and CA. So we know that area of ABCD, we have the format triangle ABC plus triangle ACD. So we have to take the one by one how to find. The first one is area of triangle ABC is what? 1 upon 2 x1 y1 x2 y2 x3 y3 1 1 1. We have to take the both the three vertices simultaneously. So we have to take which three? x1 x2 x3 y1 y2 y3. So we should keep the values 3 4 0 5 2 minus 1 1 1 remain as the same. In this example, I use our pattern method, that is we have to fix the first row and we have to evaluate column fixing. Same trick apply. We have to fix 3 here, minus 4 here, 1 is here. So we have to keep 3 4 1 3 0 2 skipping. What is remaining? 5 1 minus 1 1. So I should write 5 1 minus 1 1. Next, middle term is always negative, that's why middle is number is 4. So I should write here 4. Then we have to skip the first row and second column 0 1 2 1. Next, plus 1 remain as the same. Then which? These first row and last column we have to skip. What is remaining? 0 5 2 minus 1. So 5 into 1 5 minus 1 into 1 minus 1. So I should put the bracket to simplification. Minus 4 remain as the same. 0 into 1 0. 2 into 1 minus 2. Plus 1 remain as the same. 0 into minus 1 0. 5 2s are minus 10. So for simplification we derive 3 into 6 minus 4 into minus 2 plus 1 into minus 10. Simplifying 6 3s are 18. Minus 2 into minus 4 plus 8 minus 10 into 1 minus 10. Simplifying we derive 16 answer. 1 upon 2 is 16 is easily divisible by 1 upon 2. So final answer 8 square unit. Now we must find the area of ACD also. So we have to take the area of ACD 3 4 1 2 minus 1 1 3 minus 2 1. These AC are fixed. Now introduce the which variable here? D. Be particular about that thing. So we have to put the values x1 x1 y1, then x3 y3, and last one which one is x4 y4. So we put in this format and we derive the formation. So 1 upon 2 is fixed, 3 is fixed, minus 1 1 is remaining, 1 minus 2 is remaining, middle minus 4 is same. We have to skip first row and middle column 2 1 3 1. Now first row last column 2 minus 1 3 minus 2. So we have to simplify minus 1 into 1 minus 1, minus 2 into 1 minus of minus 2, minus 4 remain as the same, 2 into 1 2, 3 into 1 minus 3, plus 1 remains same, 2 into minus 2 minus 4, 3 into minus 1 plus 3. Minus 1 minus of minus 2, it is minus 1 plus 2, 2 minus 3 remains same, plus 1 4 minus 4 plus 3 I keep same. Now I do the simplification.